Hi everybody in Research Methods class. This is yet another one where I felt it would be better for you to see the page in the reading packet that you need to understand rather than looking at me talking to you. The topic is quasi-experimental designs. What that means is that it is an experiment, but not a true experiment. Quasi means sort of, partially, not completely, terms like that. So here's what you need to know. There are 4 interpretable quasi-experimental designs, but we're going to start with the 4 types that are called uninterpretable. Quasi is not a true experiment because it has one of 3 problems. First of all, there's no randomness. Second of all, there might be no control group, nothing to compare it to. And the third one is when you don't have a pretest. So in other words, you're not controlling for extraneous variables. So the following designs have 1, 2, or 3 of those problems. The uninterpretable ones have more than one problem, and that's why they're uninterpretable. So the first one group post-test only. You have one group of people. The X is the intervention or the assessment or whatever you're doing, the independent variable, and the O is the measurement. One group post-test only. Perhaps there is a pandemic that breaks out, and when everybody returns back to work, they measure people and their stress levels. We didn't know to measure them before. There's no control group because we only have one place of business, so it's one group, post-test only. What if you could do a pre-test? Well, then it becomes one group, pre-test, post-test. Same example, what if you knew that the business was going to close next week? So you did have time to test everybody and their stress levels. The intervention might just be that they had to stay at home during the pandemic, and then you measure them after the fact. The third one that is uninterpretable is non-equivalent control group post-test only design. There is no pre-test. The groups exist, but they're not random. Maybe we're comparing one class to another. That's not random because you already exist within the class that you are in. But one group gets the intervention, let's say they get tutoring, and the other group gets nothing. At the end of the semester, we might measure test scores on both of those classes. We did not do a pretest, it was not random, but we're still going to test them both at the end of the semester to measure knowledge levels. The fourth uninterpretable one you will see here, non-equivalent post-test only multiple treatment group design. Sounds like a fancy name, but it's pretty simple. What if there are 3 or more groups and they all get a completely different treatment, but none of them are random groups? So 3 different kinds of medicine, 4 different kinds of counseling. They might exist 12 different colleges that the students go to. In a sense like that, it could be a lot of things. But they're not random, and they were not given any kind of pretest, but they all had different interventions given to them, and they're tested after the fact. Now we have 4 interpretable designs. This means the only real problem is a lack of randomness. It could be other factors, but in this case, just a lack of randomness. The first one looks like a regular experiment. You have a pretest, a post-test. One group is the control group. The other group gets nothing, but they're not random. They're pre-existing groups. Second one on the bottom half of the page, repeated pretest. When would you do this? Maybe you're wondering if people are getting used to their current situation and therefore you wait to test them. You test kids the first day of school and then after a month, and then you're finally going to give them the reading assignment. and then you test them after they learn how to read. That could be a good study for first graders, because maybe they're learning how to read at home or just on their own. So you might do the pre-test multiple times before you actually give one group the reading program. Maybe it's online, and the other group gets nothing. They're the control group. Sometimes you want to repeat the post-test. That's the second to the bottom. When would you ever want to do that? Well, how about a study of dieting? Once the study is over, are people going to stick to the diet? You might want to test them right when the study is over, and then a week later, and then a month later, and then a year later. That would be a lot of repeats for the post-test. You could do that of whether people are continuing to exercise, staying on their medicine, avoiding drugs and alcohol. You might repeat the post-test multiple times. And now the last one, which I've got to tell you is just my personal favorite because it's so simple yet easy. Added and reduced factors. You have two separate groups of people, again, who are non-random. That's what non-R means. However, here is what makes this so unique, interesting, yet simple. Is there a baseline amount that they're used to? Well, then you give one group more than they're used to, and the other group less of that same factor or independent variable than they are used to. For example, more homework versus less homework, two separate groups. More candy to eat as a snack, less candy. And then you can see if the kids are really hyper at the end of the study. More money versus less money than you're used to getting for allowance. More of something and less of something. Added and reduced factor. But the only way to know how to do that would be, what is the baseline amount in the first place? What is the amount that they're used to getting? So for you personally, it could be number of hours of work. What if one group gets more than they're used to?